Hello and welcome back to the Jolly Franchers YouTube channel. I am a solo developer making a murder mystery RPG called The Kid Detective, which follows all the parameters of Game Maker's Toolkit's video on what makes a good detective game. You should go check it out. It will be coming to Kickstarter soon, but if you like these videos and you want to support me, please wishlist the game on Steam. This week on Making Monkey Island, we will be animating our point-and-click character controller, which we've already made navigate around obstacles and not get stuck on walls. This week, I will be doing 8-directional movement. You can choose to do 4-directional. I am aiming this series for beginners, but if you get confused about animating your character, I have a much easier tutorial series on making a side scroller with dialogue, like Night in the Woods. It's much easier to make a game like that than it is to make a game like Monkey Island, trust me. So if you get confused at any points, drop a question in the comments. I love to help. Leave a like and subscribe to the channel and tell people about it, because making a game like Monkey Island will be very possible soon once this tutorial series is finished. So this is what we had last time. A player that moves around but does not animate and does not change sorting layers. So the first thing we're going to do is click on our player game object and open the animation window. To begin animating a player, create an animator and an animation clip. Yes, thank you. And I am going to create an animation clip named Idle Down, because we're going to go over the idle animations first. And I'm just going to open up my animations folder that I've already made, and I'm going to make a new folder somewhere named Player Animations. And if you can't find the animation window, you can always go up to the top toolbar, press Window, go down to Animation, and make the animation window appear that way. Okay, so now I have created my folder. I will save my first clip in here. And here is the animator, and we can add images into that from our project folder. And here I have my sprite sheet that I have imported. I set it to its sprite mode to multiple instead of single, so I can slice out my little characters. Because it's pixel art, I've set it to point filter, or no filter. And I've set the compression to none, so the pixels appear crisp and not blurry. Okay, and I'm going to open the sprite editor to slice up my sprites. Now, I've already sliced them, but what you would do is you would go to Slice, and this is where you can choose the pivot point for your sprites, which will be very important. And in my opinion, for this tutorial, I think you should set your sprites to the pivot point to somewhere on the bottom of your sprite, because we will be changing the sorting layer of your sprite using where the collider is on the sprite, which we're going to put at the bottom of the character. And since my sprites are made with pixel art, I'm going to go down here and change the pivot unit mode to pixels. And then when I move this little circle, it's going to snap to pixels instead of going somewhere in between pixels and distorting them. So for me, I set my pivot points to 8 or 9 on the X, depending on which way the sprite was flipped, to get the look that I was looking for. You don't have to worry about this too much just yet, because we're going to go over pivot points and why they're important in detail. You can always go back to the sprite editor and change it around. So, because we need to drag our sprites that we just sliced out, as you can see here, individually sliced, how lovely, we are going to need to drag our project window to somewhere more convenient, where we can look at both the character and the animation window. So I like to slide mine over here, and I'll drag it down so I can see my sprites. So in this tutorial, I'm going to show you how to do 8-way animation, 8-directional animation, but you can easily cut this back to 4-directional if you want. So first things first, I'm going to do the idle animations, which is just the character standing still. You can put anything here. Oh, and as you can see, my character is at the wrong sorting layer because they've dropped through the floor. So I'm going to go to my player, and we're going to deal with sorting layer maybe in the next video. So for now, we're going to go to the inspector and remember this place well. On our player game object, we're going to make the order in layer 1. Okay, now to create a new animation, we're going to click here on the down button and create new clip. And I'm going to name this idle and a different direction. Let's say right. So as I make my idle right animation, I'm going to drag in a sprite from a sprite sheet that I did not set the pivot points correctly for to show you what it does. And as you can see, the pivot point is set to the center, which is why it appears so much lower. So this is just one of the things that bad pivot point placement can do to you, can confuse you. So I'm going to drag in the replacement from the sprite sheet, and I will do the up animation and the left animation in the same way. Warning, if you are thinking about flipping your sprite by pressing the record button and flipping the X value in the inspector, this will mess up the blend tree animation that we will be using later, which I will explain right now. So as you can see here, we have our character that we are changing the animation based on angles. You see negative 180 degrees, negative 90, 0, 45, all these different angles that our player will be traveling at as we point and click them around. We'll switch them as I'm dragging the angle value up here. And these animations will blend together, and something funny is going to happen here. You see this animation flips because it's next to this flipped animation, the walking right animation. And as soon as the angle value approaches that angle, it's going to flip the sprite, and we don't want that. So make sure you make a sprite sheet with each position of your character that you want them to be walking at. Pre-make the sprite sheet. Don't flip your sprites, at least for this tutorial. And as I'm fast forwarding through me making the rest of the animations, maybe if you know why that happens in the blend tree and how to stop it, please comment below and teach me. I would love to learn. Okay, now we're going to do the walk animations, just a basic tutorial here. We're going to want to start with a sprite of your character taking a step immediately, so the player gets the immediate feedback, oh, I'm taking a step, my foot's off the ground. And then you'll want to do one where the character's feet are together after they've taken the step and brought their legs together. Then you'll want the opposite foot next, like so. And then you're going to want to put two sprites to finish off this animation, both with the legs together. Because if you just put one, it'll flash on the screen just for an instant, and it'll almost look like a glitch, or like your character has like a limp or is skipping or something. So you're going to want to put two at the end so that the animator plays out that for a second. And as you can see, wowsy, it's fast. And you can fix that in two ways. I'm going to click on one end and shift click on PC, and I'm going to drag them out. And as you can see, that fixes it. Or you can go here to the samples, change that to 30, and press enter. And as you can see, it slows down immediately. But I like the tenth of a second intervals that I'm getting here. It looks like a good pace for me. Okay, now I'm going to fast forward me doing the rest of the 8-way walking animations. Okay, when you have your walking and idling animations complete, we're going to go up here to the animator window. If you don't have that, well, it's not there. You can go up to the window tab and down to animation, and you can pull up an animation or an animator window if you don't already have one. And as you can see, here are all the animations we just made. we are not going to want any of these. So I'm going to control click and select all of these and delete them. Because what we want to do is right click and go down here, and from new blend tree, we are going to create a state. As you can see, it's named itself blend tree, which is apt because that's what it is. I'm just going to move my project window back to where it once, to get back to where it once belonged. And I'm going to name the blend tree in my inspector window, as you can see up here. I'm going to name it idle tree, because it's a tree in the end. And you're going to double click on the idle tree box. And if you click on the blend tree here, it will come up in the inspector, and it's asking for a parameter. And it's already created one when we created the blend tree, and it's named the parameter blend. And it's a float, which is what we want, a floating decimal point value. And we're going to name this angle, because we are going to use the variable of the angle that our player is traveling at to determine what animation we are going to make. So we're going to press enter, and angle will come up in the inspector now because we renamed that. So we're going to add motion field, and we are going to, if you click the circle here, it will bring up a list of the animations that you've already made in the animation window. If you go up here to the search bar, you can type in idle or walk, and the animations that you made will come up. But I like to go down to the assets folder, to our animations folder, where we put all of them, and it's much easier listed here. I'm going to press the lock in the inspector so that it doesn't go away if I click on something else in the project window or in another window. And I'm going to start dragging these in to my motion field, one by one. This is the idle tree, so I'm just going to drag in all of the idle animations. So once you've added all the animations you want, you can either drag these peaks around with your mouse, or you can go down there to automate thresholds and uncheck the box. And we can start changing the angle at which our animations play by typing in the threshold, the angle that we want them to change at. And here are the angles that I put in. I messed them up the first time, but when you walk down, it's a 0-degree angle. When you walk left and right, those will be 90 degrees. Left will be positive 90, right will be negative 90. And you're going to want to have walk up on the bottom and at the top, because if you only have the 180-degree angle that's positive, the transition between back right and the up animation will be sticky. It won't be smooth. So you want to have walk up on the top and the bottom, negative 180 and positive 180, for smooth results. Okay, so once we're done inputting those values, we're going to go up here to our base layer again, because we're in our idle tree layer. We're going to right-click our idle tree little box here, and we're going to copy it, because it's going to be easy to make our walk tree from our already made idle tree. What about that? So we're going to rename it walk tree. We're going to double-click it to go inside the layer, and I'm just going to drag in the walk animations really quick. Keep in mind these values in the threshold category, these angles you're seeing are wrong. I fixed them later. You can go back and look at that clip from a second ago. Okay, so now we have the idle tree and the walk tree layer, and we need a transition from idling to walking and back to idling again, standing still. And how we're going to do that is we're going to go up here to this plus button. We're going to add a parameter in the parameters tab, not the layers tab, the parameters tab. And we're going to add a float right there, and we're going to call it distance, because we are going to measure whether we're walking or standing. by the distance of where we clicked our mouse to where the player is. So if the distance is 0, then our player will stand still. If the distance is 1, then our player will start walking. So we're going to right click, we're going to make a transition, we can drag it all around, and we're going to connect it to our walk tree. And in here, we're going to go down to conditions, press the plus button, add the distance condition, and if the distance is greater than a very small number, 0.01, then we will begin walking if the distance where we clicked to our player is greater than 0.0. We're going to have to go up here to has exit time and uncheck that and make the transition duration 0 so that the animation changes immediately back to walking. And once we're done with that, we're going to make a transition back from walking to idling because we need to be able to stand still again once we begin walking. We're going to go down here, add the condition distance, and we're going to make it less than 0.01. So when the distance from where we clicked to where our player is less than 0.01, we will stand still again. Uncheck has exit time and make the transition duration 0. And if we press play, nothing should happen. So now it's time to make it happen in our script, and we're going to go in and we are going to add a variable, an animator variable, private animator, animator is what I'm going to call it because that's what it is. And we are going to need to tell the computer what animator that is. So here in the start method, I'm going to put our new animator variable we just made is equal to get component animator. And that's going to tell our script here exactly what animator we're talking about. We're talking about the component animator that we added to our player game object. And you may not have known that we added it to our player game object because we did it when we pressed create animator and animation clip. But as we can see on our player game object, we go down here and we can see an animator was added. And that animator is where we put the idle tree and the walk tree. So now that our script knows what animator we're talking about, we're going to make a new method, a private void that I'm going to call update animation. And if you type everything exactly like I type it, with all the parentheses and the brackets, it should work just like mine. So I'm going to type in the brackets, and we are going to, even before we type anything into this method, we're going to add it to our update method so that the animation really is updated. And I'll type it in exactly how I spelled it down there. Autocorrect will help me, and I'll put a semicolon afterwards. Okay, so down here in update animation, we actually need to figure out the angle that we've been making our animator all about. So I'm going to make a new variable called angle, and I'm going to set it equal to a handy-dandy function called mathf.atan2, which returns the angle in radians whose tan is y divided by x. This will basically give us the angle in radians, which I personally don't know how to use, between 2 points. Now, we don't have the 2 points yet. We're about to figure out what those 2 points are. It'll be the position of our follow spot and the position of our player, the position where we click and the position of our player. So we'll give it those variables in a second. But for now, I am going to multiply it by a handy thing that will convert the radians to degrees. It's another mathf function called rad2deg, which does exactly what it seems like it would. And that just makes it easier for me to work with. I know angles on a protractor better than I know radians. And so now here I am going to figure out the x and y points for our atan2 function to figure out the angle between the player and the place we clicked on screen, the follow spot. So I am going to make a vector2, I'm going to call it direction, and I am going to set it equal to transform.position, which is where our player is, the position of the transform on our game object, and I'm going to subtract it from the follow spot's position. Now, as you can see here, it doesn't like that because our transform.position is a vector 3. It's a list of 3 coordinates, and the follow spot is a list of 2 coordinates. So we need to make the follow spot into a list of 3 coordinates, which is actually quite easy. We are going to cast it as a vector 3, which is a 3-coordinate, a list of 3 coordinates. We're going to list the follow spots x, the follow spot dot y, and the transform dot position of the follow spot on the z-axis. Oops, not brackets. Transform dot position dot z, because we do not want that position to ever change for our follow spot. Okay, and now it's happy with that. So now that we have this direction variable, we can go ahead and type direction.x and direction.y in our atan2 function. And very simply, I know this seems like a lot of trigonometry, and it is, but this will determine the angle between where we clicked on screen and the player, which is what we need for our animator. So I'm going to go in and type in animator.setFloat, and because the animator won't automatically set the angle parameter that we created to the angle variable that we created here, I'm going to tell it to set the, in quotes, variable named angle to our variable named angle. And as you can see, it told me what to type there. So this will set our angle parameter in our animator, but not the distance parameter. And so we will never go from idling to walking if we don't change it. So I'm going to make a new float named distance, and we are going to figure out the distance between the follow spot and the player. I'm going to type in vector2 and a handy function dot distance, and it allows us to figure out the distance between 2 points, which is great because that's exactly what we need. It takes in 2 vector 2's, so we're going to type in transform.position, and that's the position of the player. And I'm just going to type in follow spot here because follow spot is a vector 2 variable that we created that changes based on where we click the mouse. And now I'm going to make an if statement using this distance variable, because if we're not moving, if the distance between the follow spot and the player is, if the distance is greater than 1, well, we want to move, we want to change the angle of our animation. But if we're standing still, we don't want anything to change the angle of our animation. We want to stop in the same angle that we were walking. Say we were walking right, we would want to play the idle animation that idles right. So I'm just going to copy and paste everything about the angle into this if statement so that we only change angle when we're walking, when the distance between the player and the follow spot is greater than 0.01. And now I'm going to add a line here to let the animator know about the distance variable that we just created. It'll be the same function we used before, animator.setFloat. I'm going to type in the distance variable in quotes that we used in the animator, and we used the same exact spelling for our variable in our script, which I like personally. And as you can see, our player is walking, and they stop when they reach the place that we clicked on. That's amazing. It's already working. Look at these animations. But as you can see, when we click outside the wall, when we click to a place the player can't get to, the player keeps walking just straight into a wall. So up here at the top of our script, I'm going to make a private vector2 called stuck distance check, because we are going to perform a check to determine whether we're stuck against a wall. I forgot to type vector2. Okay, a vector2 stuck distance check. There it is. And we're going to do a simple check to determine if our position is the same as the last time we took a step, the last time we changed angle. So I'm just going to put down here stuck distance check equals our position, so that every time we walk, we get a new check about where was the last position you were when you took the last step, basically. And up here, I am going to put an if statement that determines if the last position we were when we took a step is the same as it is right now. So I'm going to use the vector2.distance method again, and I'm going to type in the place that we were last walking, the stuck distance check, and the place that we are now. If that distance is 0, if the distance between the point we were before and the point we are now is the same, if the distance is 0, then we don't want to keep animating that we're walking. We are stuck. So animator dot set float, and we are going to set the distance variable back to 0, because the distance variable is what determines if we're walking or not. And right after here, I'm going to put in a simple statement that, you know, if we are indeed stuck, we want this function to stop. We want to return from this function. And so it's not going to do anything after I say return, after I type in the line return. And if you type all of that in, so with all of the syntax, you will achieve this result. We are no longer walking into walls. The motion is smooth. We're not getting caught on the walls. Our animation is going in all 8 directions, or 4, however many you wanted to add. It can do it. But you can see we still have the problem that our sorting layer is not working. We can walk right up onto this desk, even though we should have to jump up on the desk. We should be pictured behind the desk. Okay, that's it for this week. Next week, we will cover sorting layers like I have in my game, Kid Detective. You can go in front of a building and then you appear on the other side of it. Or in the case of this example, your feet won't appear above the desk when they should be behind the desk. Until then, stay jolly.